Let us take a few examples of redox reactions in order to understand the reducing agents and oxidizing agent concept. Let us take the reaction of zinc solid with copper ions aqueous. We know that we can take, to understand this example of zinc and copper, we can take a beaker in which we can assume that we have taken copper sulfate solution. So it will be blue colored solution, and in this solution we places a zinc rod. Now, since we know from the reactivity series which we have done in the lower standards that I think you all will be able to recall the reactivity series. Now, since we know the zinc is lying much above than your copper, we know that zinc is much more reactive than copper. In what sense? In the sense it is much more reactive in terms of losing electron, and it's more electropositive in nature, and it more readily loses electrons. So the moment you places this zinc rod in copper solution, copper ion solution, the zinc gets oxidized and it turns to Zn2 plus ions. It turns to its aqueous medium and it makes this copper to get reduced. So this copper gets reduced here. The zinc gets oxidized. So this is how the redox reaction takes place. But what you need to understand is, slowly and slowly what we will find is that the blue color of this copper ion solution turns to what? Colorless. How it becomes colorless? Because whole of the copper ions which are giving blue color to the solution gets reduced to copper, and zinc gets oxidized to zinc ions. Zinc ions doesn't give any color. They are colorless. It's a colorless ion. So it is not going to give any color to the solution. So that is why it means what? Zinc is compelling the copper ions to get reduced. So zinc here will be your reducing agent. In short, it is called Ra. And your copper, since it is making this zinc to lose electron and it is accepting those electrons readily, so it is acting as an oxidizing agent, which is also called OA. So we can take very common examples which are taking place around us in our day-to-day life in order to understand what exactly these reducing agents and oxidizing agents are. So one thing which we can also make out from this system is, higher is the position of an element in this reactivity series, more electropositive it is, so stronger reducing agent it is. Lower is the position of an element in the series, more readily it accepts electrons, takes out electrons from the other species, so the better oxidizing agent it is. So remember, the lowermost is the strongest oxidizing agent. It can take out electron from any species. On the other hand, the topmost one is your strongest reducing agent. It can give electron to anything, and soon you will be able to know when you will be doing your S block or you will be doing electrochemistry that the series starts from lithium. The topmost element is the lithium, which is the strongest reducing agent because of its very small size and high hydration enthalpy. It is the strongest reducing agent. That is why all our mobile phone batteries, all our camcorder batteries are of lithium ion, contains lithium ions. So this is how we can categorize. Lower is the position, the better the oxidizing agent is. Higher is the position, the better the reducing agent is.